Hello and welcome back to our mini Rust in Rust series, where we are writing like a little programming language that the syntax looks really like Rust. It won't really work like Rust. It'll work a bit like Python, but with type checking. Anyway, my name's Andy and we're writing a little programming language. Last video, we really got into the weeds of changing the way our type checker worked, so that instead of it just like looking at our syntax tree and saying, is that okay or is it not okay? It gives us back a syntax tree that has type information inside it. And the immediate excuse for doing that, and it was a nightmare and I'm so sorry, and hopefully this video is more fun. The immediate excuse for doing that was that we needed it here or somewhere like here, which is that we are trying to build an error message to explain what went wrong. And we've been lying and just saying that the type of an operation, like a 3 plus 4 or whatever, was integer, even though it might be like 3.0 plus 2.1, which is a float, not an integer. So I've noticed, I've just opened this up because this is where I want to start. I want to actually use the work that we've done to stop lying here. But I've noticed that we're currently displaying a syntax tree, and in order for us to be able to not cheat, we need to be not displaying a syntax tree but a typed syntax tree. So I'm wondering why we're still asking for a syntax tree in this place, and so something's wrong. And I guess what I will do is comment out this and see what error messages we get, because we shouldn't be using the display functionality for syntax tree in a place where we actually need the type information, so we need a type syntax tree. And we found it. So here we are. This is the place that uses this error information. It's just, I don't know why it's just lost its error message. There we go. So we got rid of the ability to turn expression into a string. And yeah, well, look, we're turning this expression into, hey, you know what? This is going to fix our problem that we had. So our problem was that we didn't want to, this is so nice. We didn't want to calculate this string up front and then use up expression here. And then need this expression as a string here. And because we're now getting out right-hand side as a typed syntax tree instead of a syntax tree, we can, in here, we can say right-hand side dot as string, toString, sorry. And it hasn't been consumed because the thing that got consumed was expression, not right-hand side. And we can do the same thing actually for span here. This is right-hand side dot span. Now you should never use abbreviations. So why do I think it's okay to call this RHS? So while we're here, let's rename this. I think we should call this expression. And this expression type here, we should just say expression.type, I think. And then we don't need this variable either. Everything's good, except there's no span function, there's no toString function, but it's okay. We have a toString function which we're going to basically remove from syntax tree and have a similar thing for a type syntax tree. So where do we make type syntax tree? It's not a struct, it's an enum. So we're going to implement display for type syntax tree immediately after the general implementation of type syntax tree. And we're also going to provide a span method on type syntax tree in a second. So this is display for typed syntax tree, which means we're going to do this. I won't actually stop lying yet because we need a test to fail for us to, before we do that. Oh, and type syntax tree has a slightly different shape. So this should be, I'll just rename that token. And also statement is also, and there's a bit of to-doage here that things are still not filled out for like really like writing. We can't yet write error messages that talk about the an assignment or a statement, which we're definitely going to need, but we don't need it right now. Yeah. So I think we just need to say, I think instead of that to do there, we just need to say, turn this tree into an error message display. And then I guess we could say, if we need, no, that's fine. But is it just, it's just that this is only for error messages, right? So this, the fact that we just say integer or float or something for an operation means that this isn't a general way of turning this thing into a string. So again, we might, like I said last video, the one before, we might not want to make this impl display for type syntax tree might have a sensible way of turning something into a string, and we would use impl display for that. But for now, we're getting away with using that. All right, so that was display is now implemented, so that should have got rid of one of our errors. But also, syntax tree has a span method, I guess, somewhere. Here we are. And I think it probably doesn't need it anymore. And typed syntax tree does. Although, no, I guess it might still need it. Let's see what that is needed. Oh, there are tests for it. Where else? Yeah, not there because that's now using. Well, it's just losing my errors. Why are you losing my errors? There we go. Yeah. So those are errors about there's no span method on a typed syntax tree. So the only place where syntax tree span is getting used is here. Which is a test. So I guess we could just move that test into, so I think, are we getting to the point where we think that error messages to do with syntax tree objects are never surfaced? It's only ever going to be typed syntax tree objects that provide error messages. That, well, I guess that we're going to use Yagni. We're going to say you ain't going to need it. We're going to only implement this stuff for type syntax trees until we see some reason why they need to be also implemented for syntax trees. So we're going to get rid of this test and we're going to put a very similar test in the type checking code. But it's going to be based on a typed syntax tree. And we're going to need to fix a load of stuff to make that work. Because they're all missing types. So the type of an operation is always going to be the type of the two operators. And these just need importing. Our leaf needs to be structured differently because it now has a token. It's a struct-like thing instead of a what is the other type? Like a tuple-like thing, I guess. Yeah. Now both of those need a type. And both of those types are just exactly the same. They're just ints. and there should be a span method. So let's go back to the span method that we just commented out, and copy it, and we're going to delete it in a sec, but I'm just going to put everything back to how it was. And we've already pasted it. No, hold on. Yeah, now we need to go back into here and say import typed syntax tree. It's already got a type method. Now it also needs a span method like this. I'm not sure whether it needs to be pub crate. We'll see. And all of these are going to be typed. This is getting sadly similar to the last one where we just jumped around making incomprehensible changes. I'll try and explain what I'm doing in a second. And again, type syntax tree has a different type from syntax tree, and I really wish I'd never made them be tuple like if I just made everything struct like, even though it only had one property inside it, we wouldn't have to make these changes here. Maybe I should go back and do that to syntax tree. Okay, so now let's get rid of that whole implementation block for syntax tree because it's not used. And we don't need to even do that import, which is nice. No errors. If we run some tests, they still pass. All right, so we're in a situation where we have done a whole lot of you know what, that's from the last video as well, because again I forgot to do a commit, so don't look at the diff. I'll do the commit after this stream, don't worry about it. So what we've done now is we've added a span method to type syntax tree so that it can be used in error messages, because in error messages we need that span. And we've also implemented display for type syntax tree so that it can be shown like what it is in an error message. And the last thing that we need to do is we need to stop lying, but in order to prove that we're not lying, we need a test where this thing should not be integer but something else. So let's find our test where we assume that it's integer, which I think is here. Yeah, we're making an assignment to an F64, but we're providing an integer. And let's have another test. So we'll just say, let's say assigning an integer to a float, or to, let's say, just say to an F64 to be explicit, is an error. And now we're going to have assigning a float to an I32. We should have some other types, shouldn't we? Is an error. At the moment, we only have I32s and F64s. Those are the only types we have. So this test case is, if I've declared that X is an I32, but I've given it two floating point numbers to add up and put in there, then that's not okay. And the error message we should get is like a copy of the code. That should say I32, and oops, this should be probably moved along a bit, and it's saying I'm expecting an I32, but I found a float. So it's going to look something like that, probably about that. So if we run this test now, I missed. There's something about I is hard to type because you have to press I to start typing in Vim. All right, so it looks like that is close to being right. There's a bit of misalignment here. expected due to this. Needs to move along a bit. That's odd. Something's up here, isn't it? Oh no, it's something. Oh yeah, no, the misalignment is because it's written integer and it should have written float. So we're all fine. We're all fine. The point is, it should say float and it says integer. And this is what we've been gearing up for this whole time. We've implemented display for type syntax tree because operation has stuff in it now which we can use to find out the type. So instead of always just writing out integer, we can do a match on type, and if we're lucky that should do stuff. And a lot of this is still to do because we're not at all sure what we should be writing for a lot of this stuff, or whether we should ever be writing it. But we have two cases that we definitely are clear on because we've seen error messages from Rust that tell us what these things should look like. So we can write float when it's a float. And the rest of these to-dos are going to be easy enough to fill in once we know what the right answer is. Look at that, it passes. Okay, so let's talk a little bit about what we did here. So this whole nightmare that we went through to make the type checker just fit with the ways that all our other stuff, the Lexer, the parser, and the evaluator work, which was to take in an iterator over the previous thing, which is the syntax tree that we got out of the parser, and then transform it and return an iterator over typed syntax trees. Instead of before we were just checking, is it okay, yes or no? Now we're returning this set of typed syntax trees. What that means is that when we are in a situation where we need to explain what went wrong, we got this error message saying, I was expecting, where is it? Let's show you. I was expecting an I32 because you declared it was an I32. But what I found was this stuff, instead of just having to say expected I32 found blah, 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 which might be a load of stuff, what Rust does and what we're going to copy is it just gives you the type of thing that it found. And we didn't have access to that type information before because we were just dealing with a syntax tree. And we had figured out the type information. That's how we got the error in the first place. But it wasn't collected up into our syntax tree in a useful way. So now it is, which means we can turn a type syntax tree into a string. And in this case, where it's when it's a leaf, we actually just say the actual thing, the number or the float or whatever that it is. But when it's an operation, that could get big and long. So I'll get rid of that to do now. Now it's an operation, it could get big and long, so we just say the type of it. And that's what Rust does, that's what we do now. So it was all worth it. So now we have this nice, simple, regular structure where we lex the thing, and then we parse the thing to get syntax trees, and then we type check the thing to get typed syntax trees, and we evaluate the thing. And I think it's going to pay off for us when we're doing more complicated type checking, to be able to say, I know what the type of this expression is, and I know that there's some kind of constraint on the types elsewhere, or maybe there's no declaration of the types elsewhere, but now we can figure out the type just from that, the type of that expression. So I think having the types of the expressions hanging around is going to help us out. In future videos, I'm going to try and make us able to use this as an actual language. At the moment, it's kind of everything's very much in theory. We've got tests that pass. We can pipe things in on standard in, but it doesn't actually work like a programming language. We're not going to make like a read eval print loop yet, so you can interact with it. But I want to make it that you could give it a program that could do something relatively simple, some kind of calculation or something. and hopefully be able to print out the answer. It should work. Once we've got that going, then we'll think about, and that might involve just loops and things maybe, I don't know. And once we've got that going, we'll think about functions, structs, stuff like that. So I hope you're enjoying. Do leave a comment. Let me know. I apologize if the previous video was an absolute nightmare. Hopefully this one was a bit easier to understand. And yeah, I think we're at the point now where we have the structure of how this is going to look. And some of the stuff is reasonably okay. Like the way we're lexing, I think is close to how we're going to be lexing. The way we're parsing is close to how we're going to be parsing. There's going to be a whole lot more of it. The way we're type checking is super naive at the moment. We're not really doing any of the interesting bits of type checking yet. So there's more to do on that for sure. And then the way we're evaluating, yeah, I guess it's pretty naive too. We haven't done a lot of that. Yeah, and especially for both type checking and evaluating, we've got no sense of an environment where the variables live yet. So that's going to come later. All right. Hope you're enjoying it. Comments on what you think we should do next or how you would have done this. Really interesting to me. So get in touch. See you next time.